now that we know a whole bunch about linear equations, we're going to talk about some of their applications and how to see a word problem and be able to write a linear equation from that word problem and deal with a lot of the same ideas that we've already talked about. So the good thing about this is we're not learning that much new content, we're just learning a new way to work with that same content. Before we jump into an example, I want to talk a little bit about the language that you'll often see in a word problem. So you'll often see something like write blank as a function of blank. So for instance, write distance as a function of time. You would probably see that a lot in your physics classes. So you could also be like, it could always be like write cost as a function of time, or write how tired you are as a function of how many hours you spent on Zoom today. Really, it could be anything. And when you see this phrase, the variable that you're writing as a function, this is our output. So in our case, distance is output. And the variable that is a function of, this is input. So the variable that we've been working with in terms of x variables or the inputs, that's time in our case, and distance would be like more like the y variable, or the one that goes on the y-axis, and that's the output. You also might see this as write distance in terms of time. It means the same thing. But basically, when you see these, you'll have something like, you'll then want to create an equation where you have distance, or the output, so let's call that d, on the left-hand side, and it's isolated. It could be on the right-hand side. It's just the variable that is isolated equals, and then like some expression with t and other numbers. So maybe d equals 3t. So if t's in seconds, that'd be like you move, and d's in feet, then this would mean like after 1 second you've gone 3 feet, after 2 seconds you've gone 6 feet, and so forth. So a lot of the problems that we'll be dealing with will be written in this form. So it's important to feel comfortable with that. Two other terms that are good to know when we're working with word problems are dependent variable and independent variable. You all probably already know these from your science class, but I'm just going to do a quick review here. So our independent variable is generally our input, and it is on the x-axis. We graph this on the x-axis, versus our dependent variable is the output, and we'll put that on the y-axis, or the vertical axis. So taking an example from before, so we have our graph here, our independent variable will be here. So maybe our independent variable is number of hours on Zoom, and our dependent variable is how tired you are. The reason that tiredness is our dependent variable and not our independent variable is because it depends on that number of hours that you spend on Zoom, not the other way around. So then you would just have a graph that relates this, like the more hours that you spend on Zoom, the more tired you are. So you could also, this is the graph of, we're basically, in the previous example we did like write your tiredness as a function of how many hours you spend on Zoom. You're now graphing that. And the hours on Zoom is our independent variable, and tiredness is our dependent variable. And now we will work through an example. So take a couple minutes to just read through the next slide that we'll walk through together. Okay, let's start with A. We want to find the total number of cookies eaten as a function of hours passed. Okay, so because we're looking for the number of cookies as a function of hours passed, that makes hours passed the input and number of cookies the output. If it was the opposite, where we were looking for the number of hours passed given the number of cookies eaten, then these would switch. number of cookies would be the input and hours passed would be the output. However, because the question is looking for number of cookies as a function of hours passed, number of cookies would be the output. So I'm going to symbolize number of cookies with capital C as a variable and hours passed as h, lowercase h. Now, to write this as a linear function, we're kind of looking for the same pieces of information that we were looking at earlier in the unit. We're looking for points, we're looking for slope, we're looking for y-intercepts, x-intercepts. So let's take a look at the problem and see what we already know, what was already given to us. Well, at 5 a.m. I had eaten 4 cookies. So let's see. At 5 a.m. I'm going to make a little chart here looking for points. So at 5 a.m., 0 hours have passed. That's when the problem starts. So number of hours passed is 0, and I'd eaten 4 cookies. So we already have a point that we can work with here. And the other thing that we know is that every hour I eat 2 more cookies. So let's say 1 hour has passed. It is now 6 a.m. And how many cookies have I eaten? Well, I ate the 4 cookies at 5 a.m., so that still counts because we're looking for total number of cookies. 4, plus I ate 2 more at 6 a.m. We learned that in the problem. So I've eaten 6 cookies. Let's do one more point. After 2 hours have passed, it's now 7 a.m. I ate the 6 cookies from before, and I ate 2 more cookies at 7 a.m., so I've now eaten 8 cookies. So here we already have 3 points to work with. We pulled those out of the problem. And you all know how to how to make a linear equation from 3 points. The first step is you just need to find the slope. So I'm going to use the first 2 points to find the slope. 6 minus 4 over 1 minus 0 equals 2. I did 6 minus 4 on top because that is our rise, or our output variable is our what we'll put on the y-axis, versus our input variable, or the x, what we'll put on the x-axis, which I did 1 minus 0. So we get slope equals 2. And then, well, we could use point slope form here because we have a point and we have a slope, or we could use slope intercept form. Just instead of y and x, we're now using c and h. So c equals m h plus b. And we know that m is 2. Now we just need to figure out what b is. So let's look back at our points. We actually already have that. That was right here. That was given to us in the problem. When 0 hours have passed, that is our y-intercept, and I've eaten 4 cookies. So therefore, b is 4. So if c equals 2h plus 4. And let's just check these 2 points. So if I plug in 6 for h, if I plug in 1 for h, then I'm going to get 2 plus 4 equals 6. If I plug in 2 for h, I'm going to get 4 plus 4 equals 8. So it looks like our linear equation checks out. You could also just notice that in the problem, they specifically said that I eat 2 cookies per hour. So you could just notice that that's the slope. You don't necessarily have to calculate it out if you can recognize that when they say that, they are indeed just giving us the slope. We don't necessarily have to find all of these points, but you can find all the points. So B, we kind of just answered. Slope is 2, and that represents how many cookies per hour I am eating. So slope is often, it's a rate, like how many x's are you doing per y. So whatever concrete things you're dealing with in that problem, it'll be a comparison of those 2 things. So C is asking us to find the domain of the function. Go ahead and give that a shot on your own, and then when you're ready, unpause the video and come back and we will talk about it. So the domain of the function is concerned with all the set of possible inputs. So in our case, we're talking about hours passed. And we know that h has to be greater than or equal to 0 because that's when our problem starts. If h was less than 0, that wouldn't really make sense. You can't really have -1 hours passed. And also, the problem doesn't start till 5 a.m. So if we're looking at 4 a.m., I'm still asleep, I'm not eating cookies. It just doesn't create a value that makes any sense in the context of our problems. So you would get, if you plugged in -1 here, you would get c equal to 2, meaning I'd eaten 2 cookies, but that's not what happened. I ate 4 cookies at 5 a.m. So that's one thing we know for sure. We know when the problem starts, but what about when the problem ends? What does hours passed have to be less than? Well, I didn't eat cookies past 8 p.m. That's when I stopped eating cookies. So, and at 8 p.m., how many hours had passed? Well, it's 12 hours from 5 a.m. to 5 p.m., and then it's 3 more hours to 8 p.m., so 15 hours have passed. Therefore, h has to be less than or equal to 15, as well as greater than or equal to 0. Okay, and finally, we just have to draw a graph of this. When you're drawing a graph, it's super important that you label the axes, especially now that we're talking about things other than x and y. So this is our x-axis is hours passed. Our y-axis is cookies. And then we just have to plot our points. So we have 0, 4. Make sure you label these in problems like this. And then we go all the way to, this is not going to be to scale at all, but 1534 here. Let me just connect them. And our other points are along this line, so you can label some of those as well.
Face I have found in this place that is circling all around the sun. What a beautiful dream that could fly.